Well, welcome to everybody. Welcome back to this second part of our index session today. Good morning, good afternoon, good evening. We have people from all around the world at this index conference, which is organized by the Sfen, the French Nuclear Society, and which deals with the digital transformation in the nuclear industry. So we are very pleased and very honored to welcome Thibaut KLEINER from the European Commission. He is at the DG Connect and Director for Policy, Strategy and Outreach. And we are very honored and pleased to welcome Anna Bradford from the IAEA. And she is the Director for the Division Nuclear Installation Safety, one of the pillars of nuclear safety at the IAEA. So thanks a very warm thank to be there. So we will have two keynotes from the European Commission and from the IAEA about the regulation of the digital technologies. What are the stakes, the breakthrough, and the application? Just a little bit of logistics. The audience, you can ask questions. And for that, there is a little icon with an S, which is Slido at the top of the screen. And with that, you can ask questions, or you can vote for questions already asked. And we will process first the questions with the greatest number of votes. If you don't have the Slido icon or button at the top of your screen, you can go into the chat, and into the chat, you should find a link to the Slido to ask questions. So don't hesitate to ask questions. We'll have the two keynotes and then a Q&A session. So this being said, without further ado, I let the floor to Thibaut KLEINER from the European Commission about the view of the digital transformation in the industry and its regulations seen by the European Commission. It's to you.
Very good. Good afternoon. Many thanks for inviting me today to this conference. I must say, when receiving the invitation, I was wondering why DG Connect, in the European Commission. So maybe just to introduce DG Connect, we are the service that deals with all digital matters in the European Commission. The European Commission is kind of the government of Europe. We are developing various policies, so in the digital field, from legislation that we are initiating to also providing funding to the digital sector. So in my directorate, for instance, we have the programs linked with research support, with deployment of technologies is a bit more than 2 billion per year that we fund. And we also organize industry collaboration across the EU and internationally. So when I was invited, I found it's really interesting to also bring maybe the experience of the digital regulation to the nuclear sector. I must confess, I'm not at all very familiar with the nuclear energy. Basically, my knowledge is somehow limited to when I was a child. I grew up not far from Cattenom, it's in France, a nuclear power plant. And it was quite interesting at the time because I think also to calm the worries of the population, they took us as, pupils in the schools to visit the site and explain to us, how a nuclear plant works, what are the technologies and also the safety parameters and why we should not be worried that it would be built in the region when I was growing up. So that was quite an interesting experience for me as a child. And it's true that in the country I know best, nuclear energy and nuclear safety has been also a very important feature. But I think today with the digitalization of industry and including in the nuclear sector, there are certainly some parallels one can draw from what we have been doing in DG Connect over the years, trying to come to terms with these developments. And today, briefly, what I thought could be interesting maybe to you as community is 3 points. First, why do we regulate the digital sector? What was the rationale for the flurry of regulations that we adopted in the past 5 years? I think we have covered quite some ground, but also maybe highlight the different approaches we are taking to different problems in terms of digital regulation, and also flag sometimes what we had as governance issues in this process and still ongoing. So first of all, why has digital regulation been developed so strongly in the past 5 to 10 years in the EU? Clearly, I mean, we all know that digital technologies, even though they are quite recent, have taken an essential part in our daily life. So really the digitalization of the economy and society, we saw that vividly during the COVID pandemic, is something that nobody can ignore. It is having impact on everything we do, more or less, and it is also changing the way industries operate and the way data can be used to that extent. So that clearly offers opportunities, but it also brings new risks for economy and society. And that's why at the EU level, somehow this digitalization has resulted in 2 broad sets of issues, I would say. The first one is clearly identifying problems and asking to ourselves why and if it's time to regulate, and what instrument would be more appropriate, and how to best address the risks, the concerns, the problems we identify. And here, very interestingly, we've seen over time a shift maybe from initially the approach to say, this is a fast-moving sector. You know, digital technologies go very fast, regulation takes its time. So maybe first you should try to use self-regulation. So let it to the industry to organize itself, to look at the risks and just work with maybe codes of conduct and have light touch regulation to approach this sector. We have moved away from this increasingly towards much more prescriptive regulation that is based sometimes on principles, so that it is also flexible enough to address changing modes, but it is much more enforceable and also much more based on authorities that are active. So that has been really a first issue, the scoping of regulation in the digital sector. But a second problem has been also very important for the EU in terms of the issue of fragmentation and governance. Because what we saw is that in front of problems, for instance, the role of platforms towards impacting on protection of children, or the role of platforms in channeling illegal goods in the EU, member states have reacted differently. So it means that we had the risk that some adopt regulation and others don't, and we have discrepancy between the EU member states. So that has been also a strong motivation for regulation, harmonizing across the single market, avoiding to create new barriers and new barriers to trade, essentially, in the economy. Which brings me to the second argument I wanted to bring to your attention, which is really that digital regulation somehow has taken different forms depending on the problems we were tackling. Historically, I would say that the first issue that was tackled through regulation was market regulation. And the first one was in the telecom sector, where indeed there we were starting a little bit like in the energy sector from national state monopolies. The deregulation of these markets led to an immediate problem because indeed we had to enforce this element and also avoid that it would be done differently in different member states, and therefore that somehow the weaker regulator would give an advantage to the national players instead of having a level playing field across the EU. Therefore, the need for some EU-wide regulation in the telecom sector to make sure that market work properly, and also we have the same rules applied in similar fashion across the EU economies. This is very much also the spirit we have adopted recently for the Digital Markets Act, this important regulation for platforms, where here the motivation was that competition policy had failed to tackle in due time the excesses of the market power of some platforms, and therefore ex-ante regulation was considered needed to avoid these problems and to really put rules on gatekeepers or group of very powerful market actors. And here with the idea that a level playing field needed regulation. So you see, that has been really one of the big motivators for digital regulation: make market work, avoid excessive market power, and avoid that there is somehow uneven application of market principles. The second important factor for digital regulation has been to tackle risks. And there again, there may be parallels with somehow the nuclear sector. Clearly, these risks were not immediately identified, but the more the digital technologies have been important in everything we do, the more this has come as a necessity. And I would flag, for instance, here the issue of cybersecurity, which is something that has become more and more problematic across the economy, not only criminal situations like ransomware, but also basic risks that infrastructures would be shut down because of cyber attacks, or that systems would somehow be victims to malfunctioning that are linked to digital sectors. And this is where we've worked, for instance, through the Network and Information Security Directive to have a minimal level of preparedness and safety that is an obligation we put on national governments and on critical actors. So this has been really a motivation to tackle risk, but here the approach is really have a minimal level of protection. Another angle towards protecting risk is what we are doing currently with the proposal on artificial intelligence, where there the view is that in some instances, this technology can lead to risks for fundamental rights or risks for safety in some instances. So here we have a gradation in the obligations we put to private actors, depending on the level of risk that is observed from this technology. So you see, this is a second category really of regulation: regulate to minimize risks and to protect users, consumers, or systems. And then a third category, I would say, of regulation has to do very much with the impact of digital technologies on existing industries. And this is very much somehow updating not only sector-specific regulation, but also make sure that when we look at these regulations, they are fit for purpose because they tackle the specificities of digital technologies. That's very much what we are doing currently with the Cyber Resilience Act, which is asking companies to make sure that when they have products that include digital technologies, they also there have specific provisions to make sure that these digital elements in the products are also properly scrutinized and also along the life cycle of the product made secure. So you see that here there are some lessons maybe that can be drawn from the digital sector also for other areas. And the third point I wanted to make is really that all this leads somehow to governance issues, because at the end of the day, you see that digital is another layer somehow that is on top of sector-specific legislation, but it's also another layer between the national level, the private sector initiatives that aim at protecting consumers, and also what is happening in the European or international level. This is extremely important for digital because very often we are talking about global standards, about technologies that can be applied without a specific location in a given market. And therefore, there are risks of conflicts between regulations. There are risks of conflicts between how this is implemented. And that's why it has been also important to think about how we organize this governance. One example was, for instance, in the Digital Markets Act or in the Digital Services Act, where initially the Commission had proposed that the regulation would be essentially done through national authorities. And in fact, through the debate and the legislative process, Council and Parliament considered that it would be more efficient and more effective to put the control and the regulation of the platforms centrally at the European level, so that in fact there is no risk that one country would maybe be more lenient or another one would be stricter, leading to discrepancies and also leading to a situation where all the platforms would locate in a given territory just to benefit from more lax regulation, if you want. And that's also something that is an important consideration. It's not enough to have a regulation. It has to be enforced properly and with the right degree of attention so that you provide really the results that are expected. So that's really an important issue. Who is in charge at the end of the day in terms of this regulation? How to make the various levels work together in harmony, and how to make sure that there is no asymmetry in the way the law is implemented. Now, another issue we start having is that because we have been quite active in the digital regulation, we start seeing that regulation has to be also coordinated between different pieces of legislation. For instance, we have legislation on media, we have legislation on telecom, we have legislation on platforms, and we have legislation on data and data protection. And sometimes the same company can be subject to these four types of authorities, which means that they need to work together very effectively, and we need to avoid sometimes interpretation of the same behavior being done differently depending on the body of law that you can refer to. And I think that's really for the future something that we need to consider. And just to conclude, I would point at, because of all these elements, now the direction that we are taking in terms of DG Connect and the Commission for the digital regulation, we have developed for the future what we call a policy program. It's actually very similar to what is happening in the energy field, where we have set to ourselves targets in terms of objectives for 2030, in terms of what we want to deliver for the industry and our markets. We have also adopted a declaration on digital rights and principles to make it clear what exactly we want to do at the end of the day with all these initiatives. And we are trying to make sure that we coordinate between Europe and the member states, that we organize a review of the benefits of our regulation, and that we try to avoid these conflicts between laws, between jurisdictions, and that we try to have actually a comprehensive strategic guidance for the digitalization process. So you see that all this has been a lot of work to some extent because of the challenges with digitalization. I hope that there are some maybe lessons that can be learned for other sectors, like in the nuclear energy. But what I hope is also that in the digitalization process that this sector is experiencing, we can make sure that we find the best solutions for the adequate problems. And I will stop there.
Thank you very much, Mr. KLEINER, for your very clear and comprehensive speech about the strategy, the view, the action, the evolution of the regulation of digital globally by the European Commission. Maybe one question before letting the floor to Anna Bradford. When you have looked at the impact of those regulations on the existing industry, did you find any specific impacts for security-sensitive industries such as nuclear or aerospace or other? Did you find any hotspots?
I wouldn't say that we found specific impacts as such from the regulation, but what came out through this process is that we realized that there are specificities in these sectors that may call for exemptions, and that may call for specialty in terms of the way we design the law. I mean, here I'm thinking, for instance, about the provisions we introduced in the free flow of non-personal data. That's something that we have in the market, where we recognize that security and national security in particular could be a factor that would be justified to make sure that the data is not made accessible to to anybody, and that there would be therefore safeguards for specific sectors. And I think that also in that context, we have made sure that for cybersecurity purposes, we've paid special attention that these sectors are really well covered because they are so important, and that also the risks are so significant if something wrong would happen. So I would say that this is really the attention we paid.
Okay, thanks a lot. Now we are going to focus just a little bit more on the nuclear industry and the nuclear safety with the IAEA to see what is the view of IAEA about the stakes in nuclear safety of those digital technologies, and what is the action of the IAEA to contribute to regulate this fast evolving sector. So it's a pleasure to hear you, Anna, now. The floor is yours.
Thank you very much. Can you hear me okay, Bertrand?
Yes.
Okay, great.
Perfectly.
Let me share my screen here for one moment. Okay, hopefully you can see that just fine.
Yep.
Okay. All right, so hello everyone. Thank you for having me here today. As mentioned, I'm the director of the Division of Nuclear Installation Safety at the IAEA. So my remarks are going to focus on the challenges that we see with respect to how the safety of nuclear facilities might be affected by digitalization and the activities that the IAEA is conducting to help our member states address those challenges. So let me spend just a few minutes providing some background information on the International Atomic Energy Agency, so you can see how this fits into the bigger picture. Although many of you are probably already familiar, perhaps this reminder might be helpful. As you can see here, the IAEA was established in 1957 as part of the United Nations, and our mandate is to contribute to the peaceful application of nuclear energy and is intended to accelerate and enlarge the contribution of atomic energy to peace, health, and prosperity. We have approximately 175 member states from around the globe, and some of those member states are countries that have had nuclear power for decades and have a long-standing regulatory framework, and others are just now starting the construction of the new plants and establishing their safety requirements for those plants. So the IAEA has 6 departments that work in the areas shown here, including nuclear energy, nuclear sciences and application, and my division is in the Department of Nuclear Safety and Security. You can see more details about the divisions on this slide within our department. My division is the one shown in the middle. It has 5 sections with about 90 staff. All of them work specifically on addressing topics related to safety. And the IAEA itself is not an actual regulator of all the nuclear facilities, but we work closely with regulators, operators, and other organizations. And many of my staff used to previously work at nuclear regulatory agencies within different countries. I myself worked for 20 years at the U.S. Nuclear Regulatory Commission prior to coming to the IAEA. Examples of the types of documents that we develop, which form our safety standards, are shown here, and they span a very wide range of topics related to nuclear safety matters, including digital I&C, artificial intelligence, and so on. So one of our most important safety standards says the following for the design of nuclear power plants. It says, quote, "The design for a nuclear power plant shall ensure that the plant and items important to safety have the appropriate characteristics to ensure that safety functions can be performed with the necessary reliability, that the plant can be operated safely within the operational limits and conditions for the full duration of its design life and can be safely decommissioned, and that impacts on the environment are minimized." And this is an overarching principle that applies whether digital technologies are used or not. Therefore, when these technologies are used, we must understand how these technologies will be used and what their impacts on safety might be. So essentially, when it comes to digitalization and related topics, we have to ask ourselves, might this harm or help the safety of the facility? So for example, we heard the earlier panel, as well as just in our everyday work, I'm sure that we know that the use of digital twins is something that the nuclear industry is interested in. The development of a scaled, realistic, and immersive digital twin of a nuclear power plant would allow plant workers to be trained on their duties, without actually needing to go into the real plant and perhaps accidentally disturbing the ongoing activities. And this would allow for more flexibility in training locations, timing, and scenarios. Additionally, perhaps the digital twin would allow the plant operators to simulate various maintenance activities or even accident scenarios without having to put the actual plant through those evolutions, and you can imagine how this might be helpful. However, from the safety perspective, this raises many questions. How can we be certain that the digital twin is 100% duplicative of the actual plant? And the panel discussed that a little bit earlier today. How can we know that the way the digital twin plant responds is the same way the actual plant would respond, given the long chain of events that can occur? How are the changes to the actual plant accurately updated in the digital twin, and how often are they updated to maintain the fidelity to the design? And then on the human factors front, do operators act differently when they know they are within a computer simulation rather than a new nuclear plant? And if so, how can that be accounted for? Another example is the use of completely digital control rooms in nuclear power plants. You've probably all seen what the control room looks like in a plant that is several decades old. It has many manual switches and dials, as you can see here. And in contrast, this slide also shows the proposed control room of a NuScale reactor, which is a new small modular reactor design, and it consists pretty much just of screens and keyboards. And again, this raises interesting questions. How can the regulator be sure, and the operator, that the digital INC that is some ways really running the plant will only take actions that will maintain safety? How can we make sure there are no critical errors in the software? And how can we prevent unexpected behavior from the software? When should the plant be put under manual control, if ever? One interesting question I've heard posed is, if the computers are essentially running the plant, leaving the control room operators with little to do, is it possible that the human operators in the control room will get bored, lose their focus, and then not respond in a timely way if and when a problem occurs? And aside from new plants, what if you want to retrofit your old plant's analog control room with digital instrumentation and control? How can that be done safely? And are we certain that it would improve the overall safety of the plant, or would it introduce an unacceptable number of unknowns? So these are all interesting questions, and they need to be addressed. A nuclear power plant is not a place where we want unanswered questions or large uncertainties. So the IAEA has plans, activities, and documents to help its member states address these and similar questions. In addition to the safety standards documents I previously mentioned, we have meetings, workshops, and training opportunities to identify these questions and help develop the appropriate responses to assist facilities in maintaining nuclear facility safety. For example, when it comes to digital INC systems, we have specific safety guide number SSG 39, which is titled Design of Instrumentation and Control Systems for Nuclear Power Plants. This safety standard provides design guidelines for digital systems, including guidelines for software tools. And a few minutes ago, I pointed out some of the questions related to digital INC. SSG 39 provides some advice on these topics, and it states that in digital INC systems, demonstration that the final product is fit for its purpose depends greatly, but not exclusively, on the use of a high-quality development process that provides for disciplined specification and implementation of design requirements. Correct performance of digital INC systems over the full range of conditions cannot be inferred from a combination of testing and physics models to the same extent that can be done for systems that rely only on hardware. End of quote. So in guidance such as this, we provide useful information to industry regulators and other interested parties about how to address the challenges posed by these technologies. The IAEA also has a project related to INC modernization projects within older plants. The introduction of digital INC systems in nuclear plants is ongoing, and many of the older nuclear power plants in operation have decided to upgrade their analog INC systems that are used for monitoring, control, and protection to digital as a solution to overcome technological obsolescence identified by their aging management programs. However, the demonstration of the safety of integrating the new digital systems into the rest of the existing facility is challenging for both the operators and the regulators. The IAEA will be having a technical meeting this March to compile information and experience on safety considerations associated with modernization projects, where the standards and expectations for acceptance have changed since the original plant was designed. Ultimately, we aim to support operators and regulators in their efforts to demonstrate and assess the safety of new digital systems. Regarding the issue of safe software reliability in nuclear facilities, we recently held a technical meeting that was focused on software reliability of digital INC systems for nuclear power plant safety. And of course, I would be remiss if I didn't mention artificial intelligence. This is a topic that's getting a lot of traction in the nuclear world. It's clear that efforts are being made to use artificial intelligence technology in nuclear installations. And it's being developed to support a wide range of fields, such as reactor system design and analysis, plant operation and maintenance, and nuclear safety and risk analysis. The benefits of using artificial technology, including potential nuclear safety benefits, seems clear. For example, AI can provide great support to operators for decision-making during accident conditions by providing a deep analysis of plant data, or for in-service inspection and maintenance activities to detect material defects and identify potential failures. However, the number of safety questions that I could ask about the use of artificial intelligence is very large. Artificial intelligence technologies have limitations that need to be understood and taken very seriously when they're applied to mission-critical systems such as those in nuclear power plants. For example, the correct handling of massive amounts of data and complex algorithms is a challenge. And moreover, it's very complicated to demonstrate the impact of those advanced functions on safety. And there's a need to accrue much more experience in the safety evaluation of AI applications. Therefore, the implications of AI need to be reviewed to enable the safe use of this technology in nuclear installations. So to explore these matters, we've launched a project on safety considerations on the use of artificial intelligence in nuclear power plants. And the first large event in this project is a technical meeting that will be held October 2023 in Vienna. This event will address experiences in member states specific in areas related to artificial intelligence in nuclear installations with a clear focus on safety. We will soon be publishing information on this meeting, and perhaps some of you can participate. So during these remarks, I presented just a few of the questions and challenges related to digital technologies and nuclear safety. The IAEA is working on finding the answers, but we're not there yet. Our safety standards framework, together with feedback from member states, information we gather from our worldwide activities, and our own horizon scanning, drive our specific work in relation to the safety of digital technologies and help us decide what to focus on. We will continue to develop new technical documents, identify inputs to future revisions of relevant safety standards, and plan our work in a well-informed fashion so we can ensure that we respond to advances in technologies and the needs of our member states. So thank you very much. I hope I have provided you with some food for thought, and I look forward to the discussion. Thanks, Bertrand. Back to you.
Thanks a lot, Anna. I think, certainly we have everybody has plenty of food for thought. And I guess many consider attending the conference, the technical meeting in IAEA, or look at its outputs next fall on artificial intelligence.
Great.
Certainly, we would need a conference for each of the three topics you have been addressing: the digital twins, the control rooms, and the IAC, and the artificial intelligence. Maybe a question on artificial intelligence. We can see two types of utilization. One is to support the expertise. You gave an example with a crack examination, and it's same in the medical domain for the physicist. But would there be also, are there applications considered that are more within the traditionally deterministic field? You've talked a little bit about the design. And I would ask the question about the INC. Are there uses of artificial intelligence there, or temptations or ideas for that?
Yeah, I am sure that there are some developers that are thinking about the use of artificial intelligence when it comes to the design of plants. I think that's maybe a little bit further off, and it's not something we're concentrating on yet, just because we think there's other nearer term things that we need to work on. But I don't doubt for a minute that that's something that may be in the future.
Yeah, that's a very interesting point you have made, and perhaps which is close to a question put on the table by Igor Lebars in the previous panel, which is the link between digital twins or artificial intelligence and the safety demonstration, where we are used to be deterministic. So certainly there will be topics for the future, there is food for thought for the future there. At the European Commission, in your regulation or policy or view on digital transformation, is there something particular about artificial intelligence? Is it a topic you are addressing or considering per se?
Yes, definitely. I mean, we have actually made a proposal for so-called AI Act, or Artificial Intelligence Act, which aims precisely at tackling risks from the use of artificial intelligence in some application areas. So in instances where they can be harm to people, we are proposing precisely to have risk assessments. And I think this would certainly apply to the nuclear sector, I would expect.
Okay. So it would apply to nuclear sector, to automotive, to aerospace?
Indeed. In situations where there can be harm to persons.
Okay. So the regulation would be to make safety analysis about safety assessment.
The idea is that it applies
risk assessment.
The providers that are using AI for their services or their products to demonstrate that they have in place some risk assessment mechanism and mitigation when they use AI.
And maybe it's a field in which, good question for Anna, there could be some comparison with the medical domain, because it appears that to analyze radiography, for example, it can be, artificial intelligence can be even more effective than a physicist. But in some very specific cases, it's not the case. And if artificial intelligence does the job, how do we transfer the knowledge to the future generations of physicists?
Yes.
So
well, and that's similar. That's similar to the question about the control room, and the issue I mentioned about when do you want the plant under manual control rather than the computer control. I think some people would argue the artificial intelligence will react more quickly. It can understand more data. But I think all of us, just our human nature is I think we want a person, a real human being who's been trained and who has judgment and can see the big picture. So it's a very interesting topic to discuss.
In another domain, which is that you have addressed, about the control rooms, the INC. And we have the same question for the aeronautics, automotive, etc. Well, at least there is one in nuclear. Is the regulators have quite different mindsets about the principles on those technologies. For example, some regulators request a backup system which is fully wired. Some request backup system which can be digital, software-based, provided it's a completely different system developed by different teams with different tools, etc. So it's very heterogeneous across the world, which is a question for the industry, of course. So is there some work at the IAEA between the regulators to try to come to more homogeneity?
I think that interesting. Yes, our standards are used by many countries, which leads to sort of, I'll call it de facto harmonization. But like you said, the implementation of those standards in some countries is very different. And of course, that is their right to do that. They have their own statutory requirements, and of course, they can do that. We always, in general, want defense in depth. one way or another. If you can have a common cause failure that takes down all of your layers of defense, then that's a problem. And so whether that's addressed by a wired system or a different software system that's designed, I'm sure there's multiple ways you can attack that problem that might all be acceptable, but you have to feel confident that they are in fact acceptable.
Of course, and today the ways to demonstrate that there is enough defense in depth can be very different from one country to another, from one provider to another, of course, in the industry, but from one country to another. And I see about digital twins a question, which is the lifetime management of the digital twins. You rightly focused on this question of proving that it's representative of the physics, of the reality. And there is the question of its management over the time, when the model changes and the reality change. I think you have addressed that in your speech, but is there specific requirement about it, or what should be the rules about that?
I mean, in a way, it's no different than, as I think someone mentioned in the previous panel, there can also be differences between the paper copy and the actual plant. I think there's been cases where changes have been made to a plant and then maybe weren't gone back and reflected in the actual procedures or in the plant. So I'm not trying to say it's insurmountable, but it's one of those, you have to have procedures in place to make sure that these things are kept in lockstep and always properly reflect the status of the plant.
So we have just a few minutes left. Is there a final word you want to say, each of you?
I would just say, I think as mentioned earlier, the changes are coming very quickly. Things are evolving quickly. And I think it's something we're going to have to all keep an eye on because it's permeating every aspect, not just nuclear. And we're all going to have to adapt. So I think, at least in terms of the IAEA, we're certainly, we know this is coming. If it's not already here, maybe it's already here in some ways. And so we want to support our member states so they can properly help to ensure the safety of nuclear installations.
Okay, Bertrand.
And maybe from my side, I mean, what I would say is that clearly today the approach we've taken in the EU is to try and have horizontal regulation. So it means that it applies to many sectors. So, for instance, artificial intelligence is not that it's AI for a nuclear plant, but it's for all sorts of industries. And I would say that maybe we should try to give it a try and resist the very specific sectoral legislation as far as digital is concerned, because very often there are spillovers from one sector to the next. And what you see in digital twins for nuclear, you also will see probably in the aeronautics, in other types of sector, and therefore certainly a cross-cutting approach may reinforce our ability to look at risks.
Yeah, and maybe there is a domain which would be worth a panel by itself. We have little addressed it in the previous panel, which are the competencies. How do we manage globally in our domains the competencies within the regulators, within the industry, within the operators, to be able to face and to use and to manage the risk of this digital transformation? For sure, it's by itself the domain of the competencies is probably one of the main issue or topic of the transformation. And probably in your organization, is it something you focus on in your organization, the evolution of the competences?
In my organization?
Yes.
Oh, yes, absolutely. Yes. And I think of it a little bit, at least for operating at plants, it has to do with long-term operation. If they want to continue using these plants for decades, what are the competencies they need to modernize the plant, to make sure aging effects aren't having some impacts that perhaps weren't expected. So yes, competence building is definitely something that we are focused on in all aspects, not just digitalization.
In the Commission too, I guess.
Yes, indeed. I mean, it is actually difficult increasingly because the attractiveness of the public sector compared to also the private sector is something we sometimes struggle with. These experts are very valuable on the market, and we cannot always match the salaries that can be offered by the tech giants, so to say. But we have other ways to modernize also our skill pools, and currently we are actually recruiting for the implementation of this platform regulation. So if there are people interested, I'm again mentioning it, send your CVs.
Okay, it's well noted, and this word, as well as the whole of the session, can be replayed on the Sfen YouTube channel, and a very warm thank from the Sfen and all of the audience for your participation and your most interesting keynote speeches. So
Thank you.
have a good afternoon. See you
Thank
soon.
you. Bye-bye.
Bye-bye.